We chose this in hopes to help people suffering from disorders that are related or involved with severe stress. Diseases or disorders that could hopefully be improved are PTSD, anxiety, anorexia, and other severe panic disorders.
Firstly, CRH is secreted by the hypothalamus, located here in the brain. It is secreted into the bloodstream, shown by these purple shapes here, and then the CRH in the bloodstream travels to the pituitary gland, which is located here in the brain, so they're quite close. This stimulates the release of ACTH, which travels to the adrenal glands and in turn stimulates cortisol. In order to test the CRH levels, the aptamer, here, has been immobilized onto a test strip or a monitor. Blood is then placed on this test strip so that the monitor can measure CRH, but this will be explained shortly. So what happens is the CRH molecule binds to the ssRNA aptamer, and then the aptamer takes shape once CRH is bound to it. The aptamers are bounded onto a nanocantilever, and so you can see the CRH molecule binding to the aptamer on the nanocantilever, and this will in turn end up bending some of the legs. What a nanocantilever does is that it measures the mass of CRH bound to the aptamers, like this one. So when the legs begin to bend because of the mass of CRH seen in this leg, then the amount is quantified in mass, in any mass, usually grams, and this can be shown on a blood CRH monitor in an easy-to-read format so you can actually tell the levels of CRH in your blood quite quickly and efficiently.
As seen from the figure, no other molecule besides CRH can bind to the aptamer or be read by the biosensor. This is assured by the SELECT process, which was run to make sure that CRH was the only molecule that can be read.
Using CLX, which is the process of running thousands of aptamers in varying conditions to test their ability to bind to a target protein, in which case is our CRH.
Conditions of the SELECT process, we want them to be very close to the bloodstream of the human body. Therefore, the final conditions will include a solution that has about the same salinities and same concentrations of certain materials, the same as blood. So the solution can be about the same, and then what we will also do is make sure that the solution temperature will be the same as the average human body temperature, was about 97.7 to 99.5.
In order to measure our CRH levels, we need a signal transducer, and what we are using for a signal transducer is a nanocantilever. So what a nanocantilever does is, as an molecule bonds to the aptamer on it, the cantilever, which is like a little tooth on the cone, bends. And so that measures the mass, and this mass can be quantified onto a blood glucose or blood CRH level monitor. So our aptamer will be immobilized onto a gold plate using biotin and streptavidin conjugates to make sure that our RNA aptamer can actually bind to the CRH level.
We chose to use an ssRNA aptamer to locate CRH in a person's bloodstream. We chose ssRNA because the CRH hormone that we're testing for is a single strand of protein. So the RNA will have the highest possibility of attracting CRH in a blood pool.
Some technical hurdles we may face on the way include designing a blood CRH monitor, since it's never been done before. Then we must make sure the monitor will be able to interpret and quantify the small amount of CRH found in blood. But we already know it's pretty plausible because it's shown in blood glucose monitors, which are already used by most diabetics.
Although there are some attempts to solve this issue, ours is different due to its portability, and the test also allows the individual to be tested on their stress before they reach an optimal high level stress.
Our biosensor is very user-friendly, and like a glucose meter, it uses blood strips and pricks your finger to detect the CRF levels, and then the levels are displayed on a screen and easy to read by all users. Like all things, the public could view this as a negative. Because people will be able to monitor their CRF levels at home anytime they would like, they could misinterpret the reading, which could self-induce a panic attack, Our biosensor really helps the issue because people who suffer from PTSD and other mental health issues like anxiety and depression can monitor their CRF levels and be able to see if they're about to have a panic attack or if they might be in the realm of their CRF levels rising too high. And that way they can use their coping mechanisms that they learn and also take precautions so they can reduce the likelihood of having a panic attack.